Welcome back to part 2 of our video series on projectile motion, which is the third part of our mechanics series. In this video, we're going to be focusing on how to recognize the key features of projectile motion, which is a truly essential skill if you want to be able to solve exam-style questions, especially in an NCA Level 2 exam, but anytime you're solving problems involving projectile motion. So we'll begin by looking at an object under vertical motion, which is really where most of our key features of projectile motion can be found. And this is because any object that is experiencing projectile motion has only one force, which is to say, assuming that air resistance has no effect, all objects will experience a gravitational force pulling them down. Doesn't matter if the object is going up, if the object is going in a diagonal to the right. The only force ever being experienced on an object in projectile motion is caused by gravity down. If this is the net force, then this also therefore means that there is a net acceleration going down. Well, what is the acceleration caused by gravity? Well, this is a key feature of projectile motion. It doesn't matter what the question is, you can always immediately state that the acceleration is going to be negative 9.8 meters per second squared. Now, this is only for the vertical component of the velocity. We know that the acceleration for the horizontal component is 0, but the key is to be able to identify the acceleration in the vertical. And again, this is caused by gravity. What about the ball's velocity? Well, a really key feature of projectile motion is to recognize that as the ball is going up, it slows down, and it gets to the point just at the top of the motion where it's just about to start coming down again. Well, at this point, the velocity is 0. And we can say that this is the final velocity if we want to take that as the end point. Or we can say that this is a midpoint velocity, but no matter what we say, that velocity will have a magnitude of 0 meters per second. The other key feature to recognize is that the velocity will be negative on the way down because it's going in the downward direction. Some other key features of projectile motion are in regards to horizontal velocity. In this case, we know that the velocity does not change, and therefore the acceleration is 0, and therefore the only things we need to look at are velocity, distance, and time. Therefore, we can model it in terms of only v, d, and t. In this case, we can see that no matter where we are in the trajectory of the ball, the horizontal component of the velocity will be the same. So it's going to be 2 meters per second everywhere. What about for vertical velocity? Well, in this case, we know that the acceleration is going to be negative 9.8 meters per second squared. Some other key features we know are that at the top of the trajectory, the velocity will always be 0. So if we're going to maximum height, we can say that the final velocity will be 0 meters per second. But what if it starts to come back down again? Is there any point where we can find the final velocity? Well, yes. If we come back to the situation of equal height, then we can note that actually the velocity will be equal but opposite to the initial velocity. So if we start with a velocity of 2 meters per second, when we come to the same height in the downward part of the trajectory, we will have negative 2 meters per second. These three things are absolutely essential for modeling the vertical motion. 1, that the acceleration is negative 9.8. 2, that the final velocity is either 0 at maximum height, or 3, that the velocity will be negative, equal and opposite to the initial velocity at an equal height.